Okay, let's look at another special pattern. Something like x plus 3 squared. That's called a perfect square because it is x plus 3 times by x plus 3. So it's x plus 3 times by itself. And we call that the perfect square of a binomial because both of these are binomial expressions. So let's look at if we expand this, the traditional, what I call the long method. So if we have x plus 3, let's expand it and see what happens. We have x squared, plus 3x, plus 3x, plus 9. Combining our like terms gives us x squared plus 6x plus 9. This is what I call the long method. But if we can recognise that this is in fact the perfect square of a binomial, there is a shortcut. So if what's in our brackets is exactly the same, so x plus 3, we end up with 3 terms in our answer. The first term in our answer is the square of this first term. The square of x is x squared. The last term of our answer is the square of 3, which is 9. The middle term of our answer is if we multiply these two terms together, x by 3, we get 3x, and double it gives us 6x. So the perfect square of a binomial rule, this is what it looks like. But probably easier to see by form of an example. So let's look at the 3 examples in the textbook. Example A, x plus 1, x plus 1. Yep, this is a perfect square of a binomial because what's in the brackets is exactly the same. That includes the sign. So we're going to end up with 3 terms in our answer. The first term is the square of this first term, x squared. The last term is the square of our plus 1. Square of 1 is 1. Our middle term, let's times these two terms together. X times 1 is 1x, and let's double it, 2x. There you go. We have just expanded that. Second one, x minus 2 squared. So x minus 2 squared is x minus 2, x minus 2. Yep, what's in the brackets is exactly the same, including the sign. So we are going to end up with 3 terms in our answer. The first term is the square of the first term in the brackets. The square of x is x squared. The last term is the square of negative 2. Negative 2 squared is positive 4. The middle term, let's times x by negative 2. That's negative 2x, double it, negative 4x. There we go. Example C, 2x plus 5 squared, all squared. So 2x plus 5, all squared. That's 2x plus 5, 2x plus 5. Yep, what's in the brackets is exactly the same. So we're going to end up with 3 terms in our answer. First term, square this first term in the brackets. 2x all squared is 4x squared. The last term, let's square the plus 5. When we square 5, it's 25. Middle term, let's times these together. 2x by 5 gives us 10x, and let's double it. That gives us 20x. Last example, 4x minus 5y all squared. So the last example, 4x minus 5y all squared. So that gives me 4x minus 5y in both brackets. So yes, it's going to be the rule for the perfect square of a binomial. We're going to end up with 3 terms in our answer. First term, let's square 4x. So 4x all squared is 16x squared. Negative 5 all squared is positive 25y squared. Let's multiply these two terms together. 4x times negative 5y is negative 20y. Let's double it, negative 40y. 4x times negative 5y is negative 20xy. When we double negative 20xy, it's negative 40xy. So the perfect square of a binomial rule works if what's in the brackets, in both brackets, is exactly the same.